Okay, you guys, we're doing things a little bit different this time. You are actually taking your own notes. So there is a spot on Google Docs, if you are just coming onto the video, where I've given you the instructions, but you're going to create your own Google Doc notes and then share them with me and only me, so you're not taking them as a group this time, okay? So spontaneity. When substances are mixed, dissolving occurs without any extra energy from the outside system. It's spontaneous. If things occur spontaneously, they involve two distinct factors. So here come those distinct factors. The first factor is energy. Processes in which energy content of the system decreases tend to occur spontaneously. So what we're talking about here are exothermic reactions. Okay? If you have an exothermic reaction, you can pretty much bet that it was spontaneous, because think about it, I mean, it's releasing all kinds of energy. It didn't require energy to take place. It's spontaneous then. But endothermics can also be spontaneous if there's an increase in randomness. So when we talk about spontaneity, we don't just talk about energy, we talk about increase in randomness. Okay, factor 2, distribution of each component into a large volume. In nature, when things mix, they tend to spread into a larger volume. This process is occurring at a constant temperature in which the randomness, entropy, we're going to get to entropy in a second, of the system increases tend to occur spontaneous. So if entropy increases, it tends to be spontaneous. I want to get back, though, to this larger volume issue. And these pictures here are right out of your book. You guys should recognize these from your one-sentence summaries. What I notice is that here you've got 500 milliliters of CCl4. Over here, there's still the same amount of CCl4, but it's occupying 1,000 milliliters this time, okay? And here, this C6H14 is occupying 500 milliliters, okay? Here, it's able to occupy 1,000 milliliters. So we had an increase in its volume, the volume increase. So we would consider this to be spontaneous because it increased the volume. Okay, entropy is a measure of the dispersal of energy or a change in disorder. It's a thermodynamic quantity. Entropy increases when you go from more order to less order. Entropy decreases when you go from less order to more order. So here's some examples of entropy. Here's my cute little kids. Notice, this is back in 2002, but notice the neatly wrapped presents under the Christmas tree. Here is actually this year, and you'll notice here the chaos that has ensued. This actually was at 4:55 in the morning was when we were all done this year. So there was definitely an increase in entropy here.